Good morning. I had a question about 6.3, one of the homework questions, and in this one we were asked to calculate the standard deviation for, I think this was a set of lengths of fish from a fishing trip. Okay, so in our lesson I kind of introduced this table here as a way of getting our standard deviation, and it's basically organizing what's going on in this formula here. So in our question here, we caught, I think, 11 fish. So that would be a sample of the entire fish population in the lake. Okay, so we're going to need to use our sample standard deviation formula. And really the only difference is when it's a sample, you have this -1 at the bottom, and there's some different symbols involved. Okay, so with a sample, this X bar means the sample mean. When it's a population, we use the mu symbol, and that represents the population mean. Okay, so the symbols are kind of interchangeable depending on what data you have. So if we're going to try to calculate a standard deviation, some of you haven't used this symbol before. So what this means is the sum of. So the sum of all of your x's subtracting all of the sample means squared. Okay, so that's where this table kind of comes in handy, because if we were to write this out as an equation, it would be an extremely long equation to kind of work with, so this does a better job of organizing our info. So in order for us to find the standard deviation, we will first need to find out our sample mean. And this is pretty straightforward. We're just going to add all of our x values here and divide it by the total. So here there are 11 different fish measurements. So we're going to add that up. And I did a bunch of these calculations ahead of time. So this works out to 155.5 divided by 11. So our x bar is approximately equal to 14.1 centimeters. So the average fish that was caught was roughly 14.1 centimeters. Okay, so now that we have that, we can subtract each of our x values from that sample mean. And I'm going to go through and just fill that out in the table, and then we'll talk about it here. Okay, so this entire column here, all I did was take the x value and subtract 14.1 from it. Okay, so you can see any value that was below 14.1 had a negative value here. Anything above ended up with a positive value in our table. Okay, so just some subtraction to start. And if we square this list of values, we're going to end up with a all positive set of values. So I'll write those in here. Okay, so after squaring all of these values, basically the larger the value here, the further away the fish length was from our mean length. Okay, so this way it doesn't matter if the measurement is above or below the mean. It's just kind of a standard measurement of how far away from the mean was it. Okay? So the next part in our formula, so we started off with x minus x bar, then we squared it. The next thing we need to do is add up that total. So if I add up everything in this third column here, we get 74.9. Okay, we're almost there. So now that we have this portion here, so the sum of x minus x bar squared, we're going to square root that number divided by n minus 1. So in this case, we have 11 measurements. We're going to take one away because this is a sample of the entire fish population. So that'll give us we will get our standard deviation to be 2.74 centimeters. Okay, so now let's kind of talk about standard deviation. What the heck does this thing mean? Okay, so starting off, the larger the standard deviation, the more spread out the data set was. Okay, so the smaller the number, the closer the data points are to each other. So standard deviation is kind of more widely used compared to variance because our end result ends up in the same unit of measure as what we started with. Okay, so we're going to be tying this into normal distribution curves later on, but generally if we take our standard deviation and we add it or subtract it to our mean, that's going to roughly encompass 68% of your measurements, but we'll get into that part of it later on. So for now, all we really need to know is that it's a measure of how spread out the data is, and that our final answer is in the same units as what we started with for standard deviation. So hopefully this clears things up a little bit. I find the table is just a nicer way of doing this calculation than writing out a really long formula, because this gets pretty tedious when you have to add each x minus x bar squared for a larger set of data. All right, let me know if that makes sense, and I'll try to make some adjustments or answer any more questions. Thank you.